Okay. Whenever you're doing optimization, you're just finding the optimal value of something, whether it's a min or a max, the best case scenario with that. All right, so what we're going to do is you have to imagine that all of you are fence engineers. Let's just think of it that way. You are a fence engineer, and a farmer wants you to engineer, create, design, whatever, a rectangular fence. Okay, fenced in area, I should say, fenced area. Okay, so you are to build some kind of rectangle with a bunch of fencing for, I don't know, whatever animal it is, cows, doesn't really matter. Okay, the amount of fencing you have is, let's say you have 500 meters of fencing. 500 meters fencing. Okay, what should the length and the width be of that rectangle to have the most max amount of area? Okay, so we want the most area for this fenced in area. What do the dimensions need to be for this? What is the L and the W for this fenced in area that gives you the most amount of area with a fixed amount of fencing? So let's take some guesses first. Here. Does anybody have any ideas of what the length and width could be? Okay, if you have no idea, it's not exactly the most intuitive thing in the world. For example, is it to your benefit to make a fence that, it's super small with the L, but then super wide like this? So yeah, you said square, somebody else said square. Square technically is a rectangle, so it still follows the format that we have. Let's actually try to do this using calculus and see if it actually is a square. Then I'm going to give you a little curveball. It'll be fun. Okay, for optimization problems, what you want to do is anything that you're optimizing, in this case, we're optimizing the area. The keyword here is most area or max area. Okay, the key here is to look for those words. When it says what is the most, what is the least, what is the best, what is the nearest, what is whatever, that means optimization. By the way, this is really similar to what we've already done with increasing and decreasing, because we were finding mins and maxes there. So it's actually the exact same process, only it's an actual real world thing that we're doing. Okay, so whatever you're maximizing or minimizing, whatever you're trying to find the max or min of, whatever you're trying to optimize, that's what you derivatize. That's what I always think of in my head. I'm trying to find the optimum area. Well, really, I'm finding the dimensions, but I'm trying to find the most area. That means I have to take the derivative of the area, okay? Because the derivative, the first derivative, will tell you where things are increasing, decreasing, which means that you can find the extrema using the first derivative. We need to find the derivative of area. That's the first step. Okay, well, area, let's just write area before we do A prime right away, is equal to length times width. Okay, the problem with this is we have two variables. You cannot take the derivative of two variables for a static system. It doesn't make any sense. Okay, now you were doing the derivative of, with related rates, and there was different variables in there, but that's a not static system. It's moving. It's a dynamic system. This fence is not moving. It's just, once you build it, that's what we have. Okay, it's a static system. It's not changing. So you can't do the derivative when there's two variables. So how can I get this to be only one variable? Any ideas? All the clues that you need are actually on the screen right there. The L's and the W's, if you add them all up, it should be equal to 500. Okay, that's just basic algebra. So that means that 2L plus 2W is equal to 500. So since we have a relationship between L and W right here, we can solve for one of them and substitute. Okay, it does not matter which one you do. I tend to not like W's. Let's divide everything by 2 first. Always make everything simpler first. And it just makes it a lot easier to look at. Okay, I'm going to solve for W here, and you end up with 250 minus L. So now, check this out. If we do a little substitution here, you're going to end up with L times 250 minus L. Distribute this out, and you end up with an A equation that has one variable. You can do the derivative of that in your sleep. Let's do that. A prime is equal to 250 minus 2L. So now that we have the derivative, in order to find any relative extrema, what's the next step to do? Critical numbers. Very good. Sorry. Very good. Yes, Ryan. So we need to find the critical numbers for this. The critical numbers are found when you set the derivative equal to what? 0 or, well, the great thing about optimization is there is no undefined. This is the real world. You're not dividing by 0 anyway. with this, you could see, but you don't need to do the or undefined. I've never seen it where AP has the or undefined for finding mins and maxes. So we're not even going to worry about the zero. I'm sorry, the undefined. We are going to solve for L right here, and you get 125 meters, but again, they don't try to trick you with the units, so I'm not going to worry about that. Well, I need the dimensions for this. So if that's the L, what's the W? Right, 250 minus L, which is 125. So there are our dimensions, and if you multiply those together, you end up with the max area. It doesn't really ask for that, but it could have asked for that. So what is the max area? What's the most area that you can have? So you would just do 125 times 125, okay? So this is the max area. It wasn't asking for it originally, I just made it ask for it. And then this is the W that you can use. Here's the L you can use. Here's the max area. So it was a square. So a couple people guessed that it was a square. Awesome. Okay. Now I'm going to try to trick you. You've been warned. So I'm going to take this exact same problem, paste it down here, but I'm going to augment it a little bit. Okay. You're all engineers, so you're all super smart in this universe, this problem we're talking about right here. So you tell the farmer, you know what? Why don't we move this fenced-in area by a river? Okay, that way, your cows, I said cows, I think, right, originally? Doesn't matter. But that way your cows can drink water, so that the river's like right here above it. It's flowing that way, I guess. It doesn't really matter. But there's a river right there. I know this is a terrible drawing, but you still have 500 feet of fencing. What's the most area you can have now? Is it going to be more? Is it going to be less? How is it going to be more or less? What about the length and the width? How is that going to be affected? Wait, don't write anything down. I just want your brains right now. So I want to show you how non-intuitive this is. So is it going to be more or less area for this one? More by how much? 10 times more? 100 times more? 3 times more? 10 more? What is it? Twice the amount? Why do you say twice?
Like another width to the bottom, so when it goes up twice as long.
Okay, that's one way of looking at it. What else? And why are you automatically adding it to the bottom? What if couldn't you add it to the L too? Is it going to be a square again? Why not? It's you just have a hunch. Okay. Either way, it's not intuitive. It's not 1 + 1 = 2, right? That's intuitive. It makes sense when you look at it. You go, yeah, 1 + 1 is 2. This is like a holy cow. Wait, what is it? Really? Wait, I got to think for a second. Okay. And I love stuff like that. The non-intuitive stuff is the way to go. People tend to hate non-intuitive stuff. Okay. If you think about the majors that no one wants, engineering, sciences, that sort of thing, those are usually, they're not intuitive, So this is definitely not intuitive. It's definitely an interesting thing that you said, you said it doubles because the width can double. But what have you divided amongst all three of them?
Yeah,
No, I'm just throwing stuff out there. This is not intuitive even for me. So if people are just like, I'm sure some people can look at it and think it's nothing, but I don't know. I just like stuff like this. So now let's actually try to solve this out. And if anyone has the answer, if you want to throw it in the chat, you can talk amongst each other too. This isn't a test. He was right? Holy cow. I'm not going to lie. I've never had anyone guess that correctly in 7 years. Because it's not intuitive to say, oh, it just doubles. As you can see from my answer, it's not a square. Okay. It actually does double too, and that's an awesome guess. I've never had anyone guess that before. But it's weird because you're replacing one side and the area doubles. It's just not. I just kind of like that sort of thing. This is the whole thing about optimization. Okay, you have something that you're trying to find a min or max of. A lot of times they give you multiple variables, especially in AP. They give you multiple variables. You have to solve for one of them. Not every time, but 99% of the time, you have to solve for one of them. Throw it back into the equation, take the derivative, set it equal to 0, and you find the area. One thing that I did not do, that I'm surprised nobody called me on, was, and this is a strictly AP thing, okay, is how do I know that this is the max area? Okay, where is it proven that this is the max? This is the worst possible thing ever, but you have to do it, unfortunately. You have to make a critical number line. You're going 0. Whoops, this is actually going to infinity technically. We're going from 0 to, we did it in terms of L. So we have A prime, and then it tells us what A is doing, and you have to prove it. So if you plug in, let's just say 1 in there, this is going to be positive. So this is increasing. Plug in infinity, it's going to be negative, so it's decreasing. So if you actually did graph this out, it would look something like this. Okay. Now, clearly, this would be a relative and absolute max. And then you could prove it that way. Now, the reason this is, well, can someone tell me why this is stupid? Why do I have to prove it this way? Can anyone see why? I got in a huge, not a huge argument, but I got in an argument with AP about this when I was at the training. Because if you look at right here, the area is a negative quadratic, which means it's going to max out. So anything where the derivative is 0, it's automatically going to be the max. That you can't not use that as an excuse, that you have to prove it using critical numbers, so critical number line like that, where you're showing the intervals increasing to decreasing. Okay, but really, I feel like you shouldn't have to do that because it's a negative quadratic. It could be the only possible answer for this would be a relative max. Okay, so that being said, I'm going to ask you, what is the minimum area that you can have if you had 500 meters of fencing? And I asked for the most area. What's the minimum area you can have? Any ideas on that? Okay, so you're kind of on the right track. You're saying that it's approaching 0, right? Okay. Yeah, so what he just said is you could just put a really tiny number in for the length or the width. It doesn't really matter. So if you can imagine, the answer is there is no answer for this, the minimum area. You can have, I guess the minimum area would be approaching 0. You could say it that way. So you can have L approach 0. Your W would approach what then if W is approaching 0? And it's approaching 0 from the right, I should say, from the right there. And yeah, we're doing 500 from the left, right? You're getting closer and closer to 500. So you're getting like 499.9999999 repeating, right? Well, if you find the limit of this, if you multiply them to get the two together, it's going to approach 0. Okay, the limit would be 0, but you can't have a minimum area, long story short. And what's cool about this is this actually shows that. Okay, you can't see it on the overhead because it didn't show up very well, but if you look at the screen, it goes down forever. Okay, so it's decreasing forever. So that means it never does min out. Okay, it's one way of looking at it. Anyway, they're never going to ask you a question like that. I just think it's kind of cool to think about. What would this shape look like? You know what I mean? That's essentially, what is this shape? If I had something like that, a line technically doesn't have any dimension. I guess it's just one dimensional. So it doesn't have a length or a width. You can't think of, there's no thickness to a line. So it'd be essentially this. I mean, you could draw out a rectangle if you wanted. And this is L and this is W. Now imagine this getting infinitesimally thinner and W getting infinitesimally closer to 500. Okay, it's approaching a line, right? So sorry, that was just a little side note.